Our next speaker is Varsha Saha. She's been working as a tech lead at Flipkart for next to 100 million team. She's a JavaScript enthusiast with almost a decade of web development experience, loves coding, shopping, pets, and thrillers. Today, Varsha will be talking to us. She essentially will be walking us through her team's work of migrating three large platforms to React Native. As you can imagine, anytime we take on such projects, one of the biggest challenges is maintaining the stability of systems during this migration. Varsha will share some interesting techniques that they use to make this migration work for production systems for the biggest e-commerce company in India. Can we have Varsha on the screen, please?
Thank you. Thank you, Sarika, for introducing me. Hi, everyone. I hope you're having a good morning and a good afternoon. Um, Let me present my screen now. We'll just start right away. My topic for today is one code base to rule them all and one code base to test them all. I'll quickly get on to why I choose this topic. Before that, Sarika has already introduced myself, but just to reiterate, I'm Vasha Saha, working as tech lead in the app experiences team. I'm a dog mother, a chai addict, a JS dev, and a shopaholic. Before I get to the nitty gritty of the talk, I just want to call it out that what you as an audience would like to learn from this talk. While I have been working at the front facing Flipkart experiences team, the principles that are used in this project are easily scalable to any system. Many problems that we faced and the solutions that we used are definitely applicable to so many teams, and not just front end, it should be applicable to the back end teams as well. So it's more like a disclaimer. Quickly getting to our team and work structure, as Sarika mentioned, we started with a React Native journey 3 years ago, and before that, devs were writing their code in three separate channels for three separate channels, which is Android, iOS, and MWeb, right? And the problem with that was that there was a lot of disparity in terms of features. Android always used to be ahead, and MWeb and iOS were always catching up. And that's when we decided, like, the reasons for moving were a lot more than that, but that's when we decided that we will migrate to React Native. Today, a team of 100 plus developers can contribute to one code base. And we have like such a large team and it's still growing. We have 100 plus developers, pushing everything into master in a day. So many PRs are going on, right? We also have like a functional pod like structure where each team manages their own features and widgets. And we also touch some common widgets and features as well. So while the user experience worked out for the best, the sheer amount of devs, the 100 plus devs, and the amount of features that we were launching, right, they were huge. And just to give you an example, in our last BBD, in the last sale event that we had around 200 PR merges in a single day. That's how it is. So this is just a figurative example of how things are going on. So we have a lot of teams. I've just mentioned three of them, but we have a lot many teams going on, and they all push their code to master branch. What is the problem with this? The problem is lack of stability, which is the major concern right now for the front-facing Flipkart apps. Right? For example, two teams who are working on the same product page, which you're seeing right now, right? It's a mobile product page. One team has chosen that share icon on the top right corner, and the other team chose a magnifying glass, right? Now, which one of these is the source of truth? Who knows about it, right? So one team, let's say grocery team, chooses the left side of the image, and the discover team chooses the right side of the image. So there's no baseline. The core component keeps on changing, and there's a definite lack of stability here. So what do we do? There's a solution where we have like manual QAs who check all these bills and then see what is right and what is wrong. But even QAs are very distributed, right? We have functional QAs who are testing each of these functional features. So who do these QAs talk to? They either talk to devs, who in turn talk to designers, and the designers are like overwhelmed with the queries of what is the right baseline, right? And how do we push it into production? Or we choose a true tooling instead of manual intervention, which is why exactly I'm giving this talk, because had we chosen the manual intervention, it wouldn't have been possible to deliver this talk. So, what we essentially want to do is have a test build, have automated integration tests written on top of it, see if the baseline matches. If it doesn't match, we discard the build altogether. If it does match, we send it out to production. And hence, the testing framework became the need of TR. But why one code base to test them all? Like, we do understand, and there are a lot of blogs written. You can go to Flipkart blog and see why we chose React Native, why we chose one code base to write, to serve all our channels in. But why did we choose one code base to test them all? Flipkart, as of now, is not just an e-commerce website. We cater to a lot many user-facing constructs. We have grocery, we have games, we have travel, flight, auto. We have so many things going on within the Flipkart app. Our sanity suite itself consists of around 4K test cases. So if we start creating separate framework for each channel, it'll be like 12K test cases. Each channel will have to problem solve for their own integration testing framework, which will have their own set of challenges, right? And the automation engineers and QAs will have to learn all these three platforms to understand how the testing framework works in each of these channels. Also, addition of these features will increase the workload again, right? Because the features will go in slowly because the tests have to be written in all these three channels. Thus, it will impact our end users. And hence, we decided to go ahead with one code base to test them all as well. This is a brief high level view of how this one code base works. So basically we have a React Native code base. On top of it, we have a layer attached to it, which is basically to make any React Native code base testable. We have to have test IDs attached to each of the testable components. So we attach these test IDs, then we send this build. The build goes through a set of test cases, right? And these test cases are simple English language test cases, which are written by our QAs and automation engineers. What we have done is built a framework. Now, this framework is built on top of a lot of abstractions, which abstracts out all the nitty gritty of the channels, which is Android, iOS, and MWeb, right? So when you play these test cases, when the QAs play these test cases in the simple English language, they run seamlessly on all these channels. Before I get to what we exactly did and how we did it, I want to just touch briefly upon what these test IDs are. Basically, this component that I spoke about. In order to make the React Native code base testable, for each element or widget that we are targeting, that hey, get me the multimedia widget, or hey, get me the price summary widget, right? Each of these elements has to be associated with a particular test ID. The problem with test ID is if we start creating test IDs similarly, right? If we give all of them a name like ABC or hello, right? It doesn't solve our purpose because even the selection query becomes tougher. So you have to say, hey, hello, fifth element, right? So it doesn't solve any purpose. And the elements can shift also. So let's say today some element is at fifth position, tomorrow it is at sixth position. So you have to change the query again. What we wanted to do was create a very stable test ID. Now, in a platform like Flipkart, creating a stable test ID is very difficult, right? Because we have so many components. We have so many components that are going in and so many similar components. So we have a lot of common components like carousel, which is being used everywhere, whether it's on home page, whether it's on product page. And we have different types of carousels as well. We have a left aligned carousel. We have a rotating carousel, right? So we have a lot of carousels that are going on. So we wanted to attach these test IDs during runtime. So the test ID had to have two components. One, it had to be stable, and two, it had to be dynamic. So let's start preparing the code base, which is a React Native code base, to make it more testable. As I said, we started a React Native journey 3 years ago, right? So basically, somewhere around 2018. Now, there's a lot of legacy code base that is going on. So we could either touch this legacy code base, and for every view, which is every component, we start writing test IDs manually, right? And creating like a config of all the maintained test IDs that we have, and ask the developers that in future you have to put test IDs in your code, right? But how scalable is this, and how non-trivial is it, right? What if somebody misses out some test ID, right? So we have so many widgets, we have so many components that we wanted to touch upon that training the devs and doing this in the legacy code base was next to impossible. So we decided to automate these test IDs and generate a dynamic test ID on the fly. So this is how the code used to look like before. So we have a view and we have a rich button view inside of it. Now I want to test this view. Basically, a test ID needs to be attached to this view. So we created this function which is called a create test ID function. This function uses a certain type of unique parameters that we found in our API response. As I said, the test IDs have to be dynamic in nature because we cannot give static test IDs. So the test IDs had to come from the response itself. Now, in our response, we try to find out what are the unique keys for each widget that we are getting, and maybe a combination of that could potentially be our test ID. So we found certain unique parameters for all of these things. We chose screen type params and type in our response, but you could, if you are going to do something similar in your projects, maybe you could choose whatever works for you as the unique key. Next part of these dynamic IDs was wrapping these dynamic IDs, right? So we created a React fragment and we passed these dynamically created IDs onto our child element. So wherever we wanted to wrap this test ID, wherever we wanted to pass this test ID, we wrapped a component on top of it. And it's like a transparent curtain component. So it doesn't change the hierarchy of your views at all. The only job for this fragment is to pass this test ID. Now comes the tough part, right? How do you attach these test ID? Do you manually go and write this component everywhere? We thought not, right? We wanted to automate it. And for automation, we tried out a lot of things like a Babel plugin and JS Code Shift, right? But what really helped us right now was the AST Explorer. So if you go and search for AST Explorer online, you will be able to search for it. You simply type some sort of view, like for example, I wanted to attach this test ID on a view, so I've written a view with certain parameters, right? And on the right hand side, it will give you an exact location of how you can reach that element. So you can say, hey, for the expression statement and for the JSX opening statement with the ID hello, you want to do something, right? So you can go over the hierarchy and you can kind of create this code to reach where you wanted to attach this wrapper. And that is what we did. We wrote a code mod. A code mod is a tool library that helps you with the large scale code based refactors, right? And you can automate what you want to put in the code. You can add or you can delete using a code mod. Code mod was developed at Facebook and released as an open source. So we use the code mod module. Please don't go through this code because it's a bit. I've just literally copy post pasted what we've written in the code mod. That is not essential. The primary thing is that this is how we pass the dynamic. This is how we chose the element where we wanted to put that wrapper on, right? And then we integrated it with our build pipeline. So our build pipeline used to run like this, where all these files, all the React Native files that we written in the code base, we run this code mod on top of it. And if you can see, some 1418 files have been changed, right? Which is basically an automated way of doing things, right? Which we would have taken like ages to do manually. And voila, this is the result. So you have a test ID attached to your view element in runtime, all using the code mod during build time. So this is the part where we prepared our code base to make it testable because it was such a legacy code base, we could not do it manually and hence we had to do it in an automated sort of fashion. Now let's get on to the strategies of this one code base for testing that I'm talking about. The primary key for a one code base, right, is building abstractions and building great abstractions. If you do not build great abstractions, there's no point of writing one code base because then you're again writing three things for three different channels. And that is what we targeted on our very first go, that we build the right sort of abstractions. So if you see, this is an example of the test case the QAs or the automation engineers have to write, right? And what they essentially do is just this one line, which is cart page flow, not add item to cart and go to cart page. Now, this is a very English statement like thing that they are supposed to do, right? Add an item to cart and go to cart page. And this is it. That's the only thing that the QAs or the automation engineer or even devs have to write, right? So it's a very simple English language command which has been abstracted out, and the nitty gritty of the three channels have not been exposed to the person writing the tests. So add an item to cart. Basically, this is where our framework comes in. So what we've done is we get the cart ID and then add the item to cart, right? We use Selenium to do that. So if you see what that add to cart, if this add to cart ID is, this is exactly what we had generated in our React Native code base using the dynamic key that we had thought of. So it is a combination of cart underscore add underscore multi-widget page, which is some sort of unique parameters that are coming through our responses. The next part of this framework is how to build a baseline, right? For every testing framework, it has to assert against something. It has to assert against a baseline. Usually, this baseline used to be a designers or QAs, right? They used to say this is right or this is wrong. But we wanted to automate that process. And that is where MITM proxy came into use. So, what we usually do is whenever there's an API call, we have two modes. We have a record mode and we have a replay mode. To store baseline constructs, right, and baseline assertions, we have a record mode. When the test runs in record mode, it hits the MITM proxy server that we've put in between. The server makes the API request to our API servers. The API server returns a response, and it is stored in our file system. Right now, in the replay mode, which is where you are comparing whether you're when you're actually testing, right, when you're comparing some test build to the expected build, right, you run it in replay mode, and it hits the MITM proxy server again. But right now, the API request does not go to the API server. It returns from our stored baseline, right, and the API response is returned. Now you can assert on top of it. For record and replay mode, one basic problem that we faced was that all our calls in our system were fetch, right? So in homepage all the calls are fetch, in browse page all the calls are fetch, in product page all the calls are fetch. So we had to choose a unique combination from our stored file system. How do we return the right response? Because in homepage you could easily get a product page response. In product page you could easily get a browse page response, right? So how do you uniquely identify parameters that could potentially help you differentiate between these different API calls? And that's how we came up with the right request parameters that we wanted to use to catch these responses. So basically, we used a combination of location context, page URI, right, and a lot of the parameters to choose the right response from our mock server. Once you have the right response, you store it in a key value pair, right? So basically, this is how the key looks like. All the responses, if you see, all of these responses are getting stored. Add an item to cart, mobile, Android. You have the API call, which is post, and then you have the right key stored. So now when you hit the mock server again, when you're replaying the tests, you can get the right response from the server. And this is exactly what our QAs have to do in order to run this framework in a record versus replay mode. All they have to do is change the value from true to false or false to true. True is basically the record mode, and false is the replay mode. Let's come to the basic part of any testing framework, which is assertions. Now, there are two kinds of assertions that we could do. One is the text-based assertion, which is usually the norm everywhere, and the other one is the image-based assertion. For text-based assertion, especially for a consumer-facing app, right, a lot needs to be returned to assert just one test case. While in the image-based comparison, you just have one screenshot and that's it, right? In the front-end space, we have a lot of CSS capabilities that you need to test. For example, your padding, your margin, right? In text-based assertions, while it is possible, again, it is very, very descriptive to write all these test cases. Whereas in screenshot, it's very trivial to do that. So I just try to give an example of how text-based assertion versus how image-based assertion would work. And I was really tired of writing this itself. So if title equals Himalaya Gentle Baby Shampoo, quantity selectors equal 1, has two offers, has two buttons, it's too much to write, right? And this screenshot itself is enough for me to understand that everything is in place and everything is right. And that's why we went ahead with image-based assertions. Capturing image using Selenium is very, very easy because you just have to say driver.get screenshot as, right? And the Selenium does the magic for you. But what's more difficult is a good image comparator. So we tried using the framework, the Selenium framework itself, to understand if the image comparison can be done using that. And we tried touching upon a lot of Java frameworks as well to see if the image comparison was happening, but it was not happening properly. So in the screenshots, in any PNG images, if you see the pixels, if you zoom in, they have like these edges like this, right? And if even if the two screenshots look from your naked eye, it looks exactly the same, they'll break because sometimes the color of the pixel on the outermost side does not match what is there on the second image, right? And the images will start breaking and your tests will start breaking. So we had to find a good image comparator, and after a lot of research we came up with pixel match. Pixel match is a very small and simple JavaScript library that compares these two screenshots. And it also features accurate anti-alias pixels, which is what I spoke about earlier. And it gives you an accurate result. So you put a threshold there, and Pixel Match will say that if the threshold is breached, the screenshots and the comparison will fail. If the threshold is not breached, your test will pass. And that actually brought up our stability of our test cases from literally 10% to 90%. That's how it was. Challenges in image comparison are many. One was definitely the image comparator, the other one is the blinking content. If you see on flipkart.com, there's a lot of animated content and there's a lot of blinking content. For example, in the login page, you have an when the screenshot was being clicked. But when you were comparing it to something, the cursor was not present while the screenshot was being clicked. Right now, the two screenshots will definitely break because the two screenshots do not match. One has a cursor, the other one doesn't. Right. So we chose to ignore the elements. We chose to ignore those components where anything was animating or something was blinking, and that's why you see this black overlay, right? So we created a method called capture screenshot with ignored elements, right? So you basically pass a list of ignored elements that you want to ignore in a certain page, and the screenshot will be clicked exactly how I've shown it. We also created a set of base ignored elements that we identified in certain pages. So for home page, we knew that there were certain components like the rotating carousel or the notification icon that used to animate every time. So we tried to ignore all of that beforehand. So all of this is built inside the framework, and nobody has to write anything explicitly to ignore anything, right? Unless something new has come up, of course. Another problem with such framework is scroll and click, right? So if you see, a lot of our test cases were go to browse page, scroll up till like sixth or seventh page, and then click on the product and go to product page, right? While scrolling, you also want to test the browse page. Basically, how does the browse page look like on the sixth page, right? The problem with this is that, let's say in the recording mode, which is your baseline mode, when you scrolled when you scrolled the page was at y pixel, but in the replay mode, when you're comparing, the page stopped at y plus 1 pixel before clicking the screenshot. Now this 1 pixel difference will definitely cause the two screenshots to fail, right? Whatever image comparator you use, it will fail, whatever threshold you use. So now when the two screenshot matching failed, you know that the test was right, and there was nothing changed. It was just a movement of the pixel that has caused this issue to happen. So how do you solve for it? What we decided was that in record mode, we will click just one screenshot. But while we were in the replay mode, what we'll try to do is do like an origin shift screenshot. So we click a screenshot at zeroth position, y plus 0, y plus 1, y plus 2, y minus 0, y minus 1, y minus 2. So that is how we click the screenshots. And we, even if one of the screenshots in the replay mode matches what we've clicked as the baseline image, we mark the test as true. So the test passes, the assertion is true. Another challenge for Flipkart and any consumer facing apps which do not have the sites are not that static, the pages are not that static, is the dynamic nature of these pages. In Flipkart, every BBD, every sale event, even every day, the home page changes, right? So there's a lot of things that are changing, and not just from API response perspective. But let's say I, from a grocery team, have today decided that this deliver to address widget will be on the top, but tomorrow somebody else from, let's say, Discover team decides that, hey, this needs to be at the bottom bar, right? Now, what will happen is, whatever test case that I have written for this particular cart page, all of them, let's say I've written around 1,000 test cases for cart page, all 1,000 will fail because we are doing an image-based comparison. Even one shift has caused the 1,000 images to fail, so we have to restore and we have to change the baseline again. Now, that's a very tedious task to do, and you wouldn't want to do it every time. You wouldn't have time to do it every time, right? So what we decided is that we will go with widget screenshot more than page level screenshot. So we built a capability inside our framework where you can not just click the entire page screenshot, you could also click just a widget screenshot, right? So now in this case, what happens is that even if you shift some widget on a page from, let's say, first position to second position, uh, some sanity test cases will break where we are clicking the entire page screenshot, but most of the test cases will pass. So you just have to go and update those few broken test cases and not the entire set. Let's see how it goes in action. So this is basically the entire the testing framework does exactly how our manual QA does right now. So you open homepage, you search for Lakme lipstick, then you scroll, and then you go to a product page. Right. For the interest of time, I'm not going to show the entire video, but this is how the entire Flipkart.com is getting tested right now. And this is the result. So if you compare the two screenshots, if you see the F assured icon on the left, on the first image is a little bit shifted to the right hand side, and the F assured item icon on the next image is on the left hand side, right? And with a good image comparison technique, we are able to detect that hey, there has been a baseline shift here in the widget, and this test case will start failing. What it turned out to be, we have already written 4,000 test cases that work exactly the same on all three channels. The framework is very stable and very minimal developer intervention is required to fix the basic framework. The abstractions have reduced the effort to write descriptive tests. So as you saw, we wrote very simple English language test cases, and we did not leave it to the person who's writing the test cases to have to worry about what is the abstraction going behind it. So the abstractions are all built into the framework. The QAs and the AEs, the automation engineers are all onboarded to write tests, and it's a very small learning curve. There's no developer intervention required at all for the React Native code base to make it testable. The developers uh, even do not know. Like I'm very sure that half of the developers in the team do not know that we have such a test ID system, which where the test build goes to an automation system. Right. That is how we abstracted it all. That is how we created a framework. So we just run a command in our command line tool, and then you get the results, right? So nobody has to know about it. And the features in prod are with the right velocity, because now you know whether your baseline image is and whether the next thing that you're pointing out to is right or wrong. And definitely this is intelligence at scale. Nothing without the team, of course. We were a team of 4 developers only who built this framework for around a year. Siddhant Soni, Hemant Jain, and Sai Charan. Thanks to the team for making it possible. And thank you everyone for listening to my talk.